I'm Anil Kumar sharing with you one of the best questions on this topic, derivatives. It's a communication and thinking problem. Given function f of x equals to absolute value of x squared minus 1, find derivative of f of x. Sketch f of x and its derivative. Now, to explain you this, it is better for me to sketch it first and then go about finding the derivative. Let's try to understand what this function really is. So here I'll sketch this function. Let's say this is our y-axis and that is the x-axis. And in this, we will draw the function which is, let us say, x squared minus 1 first, right? So x squared minus 1 is a parabola shifted 1 unit down. So let me draw this function x squared minus 1 with a dotted line. Right, so this is my function which is x squared minus 1. When we say absolute value of x squared minus 1, then what does it mean? It really means that we do not have any negative portion that is positive, right? So it's flipped. So we get a function like this, which is, now we can bold this portion, it remains same as it was, and this function which I am drawing now is really x squared minus 1. So that is our function x squared minus 1 with absolute value. So this bold portion, flipping the negative part, that is the, you should say, transformation which has been applied on original x squared minus 1 function. Now as you see, derivative of this function is negative on the left side, positive here, negative, positive, and here it is does not exist, right? So derivatives does not exist here and is 0 there, right? So that is how the derivative is. And now when we understand what the function is, let's find its derivative. I hope this is absolutely clear to you, right? So that is x and y, and these points are 1, minus 1, minus 1 for us, correct? Now let's write down this function, absolute function. We have f of x as equals to absolute value of x squared minus 1. Now this could be written as combination of few functions. So let's start from left side to right. So if we have x value which is less than minus 1, in that case the function is same as x squared minus 1. Do you see that? X squared minus 1. At this point, when x is equal to minus 1, it is value 0, right? Now between minus 1 to plus 1, when x is greater than minus 1, but it is less than plus 1, it is flipping of x squared minus 1 or negative of x squared minus 1, correct? At this point where x is plus 1, when x equals to plus 1, the value is 0, right? And after x is greater than 1, it is same as the original function x squared minus 1. So indeed, this is our absolute x squared minus 1 function, right? So if I have to write its derivative, let me write the derivative here itself to explain you what is f dash x. So we'll write f dash x here in this column. So let me make this column for you. Insert it in between, right? So I'm doing all this. You have to write it in the next step. I'm doing all this just to make things absolutely clear to you. Derivative of this is 2x, correct? Derivative of 0 here, and this is a corner. Do you see that? So we'll write does not exist. On a corner, derivative does not exist. Here it is minus 2x. Here does not exist, right? And here again 2x. So these are the derivatives in the portions defined, or the intervals which we have taken. So it does not exist at these 2 points, right? But it exists at other points. So let's now try to sketch it. So to sketch it, we have these minus 1. So at minus 1, if we have, let's start from left to right again. So this is 1, and let's say this is my point 2. This is my minus 2 point, okay? Now I'm drawing all this so that it will help me, because I don't have a grid here, right? So that is the kind of my grid, reference frame. Okay, that looks good. Now, so I'm writing this as point 2, where this is 1, this is minus 2 here. Let's try to make or sketch a derivative function here. So if we are on the left side of minus 1, the derivative is 2x. So at minus 1, it will be minus 2. So at minus 1, it will be minus 2. So I'll write here, make a hole here, because that value is not really included here. If it is more towards, let's say, it's minus 2, then it is going to be minus 4. That means decreases with the slope of 2, right? So basically, it is kind of like this. Do you see that? So on this side, that is the derivative. Now, let's go to the right extreme, which is very similar, 2x. So here, if I put 1, the derivative is 2x, which will be 2. So at 1, the derivative is 2, but that point is not included. As we increase the value, it is a straight line, 2x. So it's a line which goes like this. Do you see that? So that is our f dash x for these two intervals. Now in between, we know it does not exist here, but how about, now the center portion is this portion, which is, this where the derivative is minus 2x. If I put x equals to 0, then minus 2x is going to be 0, so I get a point here. If I put x as minus 1, then it becomes minus 1 times minus 2 makes it 2 plus, right? Do you see that? 2 plus. So at minus 1, we get 2 plus, so we get a point here. But that is not included. If I put 1 here, it is 2 minus, so we get a point here. So we can connect this with a straight line. Do you see that? That straight line is f dash x. So this is a portion of f dash x in the interval less than minus 1, and this is f dash x in the interval between minus 1 and plus 1. And these lines, the bold lines which I have drawn, these represent the derivative of the function. So that is how you can plot function and its derivative on the same graph, and that is how it is going to be looking, right? Don't you think it's so beautiful? It is indeed. And that is how you do derivative of absolute function. So as an exercise, what I would like you to do is do the same thing for another function and let that function be f of x equals 2. Okay, so we'll make this function as absolute value of x cubed plus x squared. Okay, so try this out, draw this function and then show its derivative on a graph as we've done. Thank you and all the best.